Let's start. Good morning, everybody. Hopefully you're ready for an exciting hour of chemistry with your host, me, Dr. White. What the game plan today or this morning will be is, first I want to quickly go through the lab because yesterday I did the Labster lab for today, and I did as much until I finally bailed out, which I usually do on Labster labs. But remember, because you paid $60, COD, I almost said the wrong school, ECC, where I also teach, not this summer, but allows you to take 1211 this summer online. And when you go transfer to credits elsewhere, you'll get full credit for a lab course, which is a good thing. That's a good thing too. That's my second cup. First cup is always vanilla almond. Second is blueberry. Yes, I'm a creature of habits. Good ones. All right. What I'd like to do today is talk about today's lab, and it deals with, what was the name of it? Matter and phase changes distill ethanol. All right, now, you've already learned about the three states of matter: solid, liquid, and gas. And you can go between the different phases. And one example is water. Here, this bottle, which, see, I reuse my bottles. I take it off and fill it with regular tap water. And then after about a month, this one's about ready to go. I use a new bottle. But anyways, this is a liquid. If I put it in my freezer, you come back tomorrow, and if I took it out, this would be a solid. We call that ice. And what happens is you have a phase change. Now, the other thing I could do is take this water, put it in a pot, put a flame underneath. How do you like that, Ann? Flame underneath, and it would boil, and the water would become a gas. Now, when we get into, unfortunately, I should have changed the order of this lab, but it still works all right now. Later, when we get into solutions chapter, I'll teach you about boiling, but right now, let me do a real quick thing and give you a quick introduction to boiling. All right, everybody should see my whiteboard. Thank you, thumbs up, people. Hang in there. All right, it's time to find out once again why Dr. White will never be an artist. It's even bad by my standards. Let's try again. Here you have a beaker of water. This is a Bunsen burner. This is a flame. And you'll heat the water up, and you'll see little bubbles here. And what are in the bubbles? Water vapor. And the bubbles come to the top and collapse, and up above here, you have given off water vapor. Vapor is a way of saying a gas of a liquid, of a substance at a temperature where it might be a liquid. Now, boiling point, and I'll go through this later on, is when the vapor pressure equals atmospheric pressure. So you have the water vapor here, and then you have the atmospheric pressure, which is all around us. You learned about that in gases. That's why I put this in the gas part. And when these two are equal, you measure the temperature with a thermometer. Oh, boy. And that temperature is the boiling point right here. So if you have substances with different boiling points, you can separate them by slowly heating them. The one with the lower boiling point will boil and the vapor will come up here. And then later on, the second one. All right, this is called a distillation apparatus. In the round bottom flask, you put whatever liquids or mixture you're trying to separate. Then you have a still head or distillation head. You have an adapter with a thermometer. These two go together. This is called a ground glass joint, which allows you to connect things together. This is more an organic lab. What happens is, and then if you have something boiling here, the vapor comes up here. This is connected, so it can't go out here, and it goes here. And here you have the condenser. Now the condenser is two tubes, a inner tube that goes all the way through, and an outer tube here, which is called also a water jacket. And water goes in here, comes out here, and it fills this whole tube right here with water. And that water cools the vapor here, and it makes it from a gas, vapor is a gas right here, to a liquid. And what happens is the liquid comes down here and drips down into a container, either a round bottom or another one. Now, this is a vacuum adapter. And what you don't know, and I'll teach you when we get into solutions, is if you pull a vacuum on this whole thing and it's all connected, instead of a beaker, you have another round bottom, then because the pressure inside is lower, the boiling point gets lower. Don't worry about this. Now, in today's lab, you're going to be doing some phase changes. The first part, have some fun with. They take you out and they have a scenario where you've got to help someone make good ethanol. Because when you make ethanol by fermentation, you have both water and ethanol together. And how do you separate the ethanol from the water? Ethanol has a lower boiling point than water, so you heat it up in a distillation apparatus. And that's how you purify it. Let's go back 1 second. Hold on. The stoichiometry one, all you got to do is that's the one where I did the magnesium oxide lab, I think is stoichiometry. Hold on while I look at my syllabus. Yeah, on Lab 7, you'll see I have on Blackboard. Do I still have Blackboard running? Yes, I do. Hang in there. For that one, Lab 7, just don't do the Labster one. Do mine. Hold on while I jump around. If you look at the assignments area, you'll see determination of empirical formula of magnesium oxide. I went through that. Let's see, last Thursday. Go look at the video for last Thursday on YouTube. You can see how I just described that. If you're running a little late, whoever asks, don't tell anybody, but you can hand it in tomorrow. I won't take off points. This summer, because of everybody and with things coming up through work and whatever due to COVID-19, I'm not tough like I normally would be and say, you're late, I'm going to take points. I'm more laid back. Too many more important things are happening in our life for me to get all bent out of shape over 1 or 2 points. And since I'm not commuting, I have extra time. Since I'm not leaving my house, I have extra time. Does that answer everybody? Oh, by the way, yeah, Labster is. But anyways, think of the bright side. It's allowing you to take Chem 1211. So for an extra $60, that's a good deal for you. All right. So what you're going to do today and today, oh, I know where I was going. Hang in there. I lost my train of thought. Now, this whole thing is called the distillation apparatus. And hold on 1 second. I'll be right back. I just remembered something. I'm back. Back in graduate school, I did a lot of distillations. And unlike in industry, when you're doing stuff in grad school, you work on very tiny scale. And a couple of years ago, I saw on eBay, yeah, I buy a lot of stuff for collections on eBay, something I used in graduate school. I had one of these when I saw it on eBay. I went and got it. This is a micro distillation unit. Here's the still head, thermometer goes in here. Here's a very tiny little condenser. Water goes in here, comes out here. It condenses the vapor in the inner tube. Here you can pull a vacuum. And then I also got, no, I didn't steal these. I got these on eBay. This is a round bottom. This goes like this. When you're collecting it, you can have it like this or something else called a cow, which you can have a couple of these and turn them. And that's how you do a distillation. Is that cute? If you ever wondered, is Dr. White really a chemist? Now you know if he collects this stuff. Hold on, this is very important in my life. I'm gonna put it somewhere safe. Now, back to what I was showing you. This is a distillation apparatus. And for short, it's sometimes called the still. And if you are familiar with moonshine, moonshiners use a still. What they really have is a crude elementary still where they have a pot or place where they have their alcohol and water and mash. They heat it up and it comes up, and they usually have a copper coil, because sometimes they're out in the middle of a forest because they don't want to get arrested. It's illegal, and they don't have water, so the air will condense it, and the longer the copper tubing, the more air to condense the vapor into a liquid. Then they have it going into a container, and then they sell it, and it's on TV. They show that. Have I ever done my own still at home? No, it's illegal. And I don't need the police coming and saying hello to me, which I don't do that. But next time you see that and hear about moonshine, and that's all they're doing is just making and distilling alcohol. And all the companies that do it legally are to have huge distillations. Now, in Labster, just do as a first couple of questions, then you can bail out if you don't want to go to the end, and you'll get your 11 points. Shh, don't tell anybody, okay? Any questions about today's lab? Going once, going twice. I better get going. Everybody see test 2 review? Thank you, thumbs up, people. I got you trained. All right, test number 2. Let's go through this. What you're seeing on the screen is available in the lecture section of Blackboard, so you can download it. I talked about where the electrons. The electrons are in shells. Shells are where the electrons have approximately the same energy, same distance from the nucleus, center of the atom. And the shells have fancy numbers, 1, 2, 3, 4. Now, shell 1, you have 1 subshell, 2, 2, 3, 4. Now, the subshells have names, S, P, D, and F. Now, S is the lowest energy, F is the highest, which is another way of putting it this way. The subshells are S, P, D, and F. S has 2, P 6, D 10, F 14. Remember my gift to you. You only have to know how to do up to magnesium for electron configuration. That's my gift to you. Enjoy it. And we went through and looked at the problems section, practice problems. Also look at the videos because they're on YouTube. I've been keeping up. And electron configuration is a statement of how many electrons an atom has in each of its subshells. Remember, use numbers, letters, and superscript numbers. This is all the electrons. And we went through this. Next, valence electrons. You should know the valence electrons are the outermost electrons of an element. The number of valence electrons of an element can be found on the top of the column of a periodic table. And next, when you have valence electrons for an element, you can show that by Lewis structures. And Lewis structures only deal with valence electrons. Common mistake on test 2, so pay attention so you don't make the common mistake. When I asked you to do electron configuration, this is all the electrons. When I asked you to do Lewis structure, those are only valence electrons. Sometimes I see students do all electrons on a Lewis structure. Nope, that's wrong. You can only have 8 maximum valence electrons for any element. And to draw a Lewis structure, take the chemical symbol for that element, put 1 dot on each side for a valence electron, and if it has more than 4, you put 1 on each side before doubling up. Now, next I started talking about chemical bonds. You should know ionic bond. And I mean, you should know how to describe what is an ionic bond. That's the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. Again, the key thing here is transfer one or more electrons from one atom or group of atoms to another atom or group of atoms. Now, covalent bond, you should know, is the sharing of one or more pairs of electrons between atoms. Now, important thing I'll never ask you on a test, but the octet rule, and that's atoms of elements lose, gain, or share electrons in such a way that their electron configuration is identical to that of nearest noble gas nearest them in the periodic table. What I mean by that is elements try and have the same number of valence electrons as the nearest noble gas, which is 8. Now, when we talk about ionic compounds, elements, some of them form ions, and electrons can lose or gain electrons to have the same number of electrons as the nearest noble gas. So if I ask you, which we did in the practice problems and also in class, go back and look at the videos on this, write the ion that calcium forms. Well, how do you know what to do? You say calcium and you look at the periodic table. Remember, the atomic number gives you number of electrons, number of protons. Calcium has 20 electrons, 20 protons. The nearest noble gas, hang in there. The nearest noble gas, calcium, is here. You have krypton way over here, but you have argon at 18, only 2 away, which is closer. So calcium wants to have 18 electrons. And therefore, if it has 18 electrons, it doesn't lose protons, so it still has 20 protons because it's now stable. Every electron is a -1, every proton is a +1. Do the math, add it up. And the ion, how would you write it? The old way, which Dr. White still does, +2, or you can do the newer way, which I don't do, but will be correct on test, is 2+. Next, I asked you how to write the formula, simplest formula for ionic compounds made up of the following ions. How do you do that? You know that for all molecules, the sum of ionic charge in a formula is always 0. And let's do a real quick one. Why don't you think, and I'll give you a whole 30 seconds, write the formula made up of calcium +2, nitrite -1. What would be that formula? Normally at this time, if we're in a class, I'd be looking around the classroom and say, when you're done, look up and smile. And that way I can know when students were done. All right, time's up. Put down your pens and pencils. Let's take a look at this. This is a +2. This is a -1. All molecules have a net 0 charge. Does this add up to 0? No. You can't change the charge, but you can change how many. To get this to 0, I need 2 of those. How do I show that? One calcium. Now, this is a polyatomic ion, so when there's more than one, we put it in a bracket. How many do we need? 2, so subscript 2, and that's how you do that. We did that in class. All right, next I talked about Lewis structures for molecules. Remember when you draw the Lewis structure, you have bonded electrons. Those are pairs of electrons that are shared between atoms in a covalent bond. And you have non-bonding electrons. Those are pairs of valence electrons that are not involved in electron sharing, otherwise known as a covalent bond. Now, you should know, when we talk about covalent bonds, there's a single bond, and you should know a single bond has one pair of electrons being shared between 2 atoms. A double bond has 2 pair of electrons being shared between atoms. A triple bond has 3 pairs of electrons being shared between atoms. Next, I showed you, and I don't have it here, how to draw the Lewis structure for compounds. And I would ask you, draw the Lewis structure for oxygen gas. If you look at oxygen, it has 6 valence electrons, and I'll let you try that now. I guess since not all of you have your video on, when you're done, give me a thumbs up, either if you have your video on, or use the clapping hands or thumbs up from Zoom. Anybody need more time? All right, looks like everybody's done. Let's do this. How do we do it? Well, if we look at oxygen, the Lewis structure is this. And if I have 2 of them, and notice each one has 2 unpaired electrons. And this oxygen says to this oxygen, I have 2 unpaired electrons, you have 2 unpaired electrons, let's share. And they do. Now, the non-bonding electrons on each atom of oxygen are still there. I put them here, you can put them on any side, and this would be your answer. Now, I could also ask, what kind of bond exists between the 2 oxygen atoms? I'll give you 2.8 seconds to think about it. 2.4, 2.6, 2.75, time's up. Notice here, we have two pairs of electrons. Two pair of electrons, it's a double bond. And that's how you do that. We did other ones. Now, remember, whenever you see, I'll do it up here. Whenever you see an alkali metal, like this one, this is always going to form a cation, and the alkali metals do that. And then I went through this, but let me just show you it again. The electron that was on sodium goes to one of these here. So this has an extra electron, and this would be the Lewis structure for sodium hydroxide, which is an important chemical used daily in the American chemical industry. And that has both an ionic bond and a covalent bond in it. And you should know how to do that. All right, let's move on. Next, we talked about one of my favorite areas, moles and mole calculations. First thing you should know, what is a mole? Now I have one definition, a chemist counting unit. I could have also, what is a mole, said Avogadro's number of atoms, and this should be superscript. This one here too. A mole is Avogadro's number of atoms or molecules. And you could also put down a mole of an element is the atomic weight of an element. That's a mole. And a mole of a compound is the molecular weight in grams of a compound. So those are all things that a mole. Don't forget, my birthday is coming up the end of December. My all-time favorite gift I really would like is just a mole of pennies. It's just pennies, and that's 6.02 times 10 to the 23rd pennies, which is 100 million times a billion, 100 million billion. That's a lot of money. It's just a mole of pennies. Let's see. All right, now, in the past, I would make students memorize this and use it on a test, but that's the past. Nowadays, this will be an important information, but you should know how to use these. You should know mole of an element equals Avogadro's number of atoms of an element. A mole of a compound equals Avogadro's number of molecules. 1 mole of an element equals the atomic weight of an element in grams, and a mole of a compound equals the molecular weight. And the molecular weight of a compound is the sum of all atomic weights. Now, we did a number of problems, such as going from grams to moles, or moles to grams. You should know how to do that. I did these. You should know how to go from mole to atom or molecule, or to reverse, atoms or molecules to moles. And how do we do that? Guess what time it is? We used your good buddy, your good friend, I have to get that in, unit analysis. And we went through a lot of it. Remember, unit analysis, what you start with, you look at what you end up with, and then you have a ratio, and you put what you're trying to get to on top, what you're trying to get rid of unit-wise on bottom, and we'll wait for my bar to come down so I can go to here. And you use these relationships to do that. Do we have time? I do. I'm going to help you out. Why don't you try and set this one up, figure out what are you trying to find, what are you given, and then use your good buddy, your good friend, unit analysis, and I'll help you out even once more. One mole of a compound equals the molecular weight in grams of a compound. Go.
Dr. White, we can't see. We can't.
Oh no, now can you see it? All right.
Yes.
Let me go through it again. Instant replay. Oh, I'm so embarrassed. Oh. Anyways, how many moles of water is this amount in grams? The molecular weight of water, and by the way, thank you, Suela, for letting me know, equals 18.0 grams, but you should know how to calculate that. And an important information for test number 2, you'll be given 1 mole of a compound equals the molecular weight in grams of the compound. Now go ahead and try it. And you don't have to calculate it, just set it up. Oh, important public service announcement for test number 2. It pays to show your work. If you just put down an answer and it's right, I'll give you full credit. But if you just put down an answer and it's wrong in any way and don't show any work, I'll give you 0 points. But if you put down, show your work, and say you pushed the wrong buttons on your calculator, but showed me the work and it's correct, I'll only take off 1 point. So it always pays to show your work. All right, I think everybody's done. Let's do this. What are we being asked of? So one bad thing about this pen, my finger, if I don't hold it right, hits the buttons on there that I don't want to. All right, what are we trying to find? How many moles of water? What are we given? It's time to use unit analysis. This is the only number we have to start with. If there was some ratio conversion, what am I trying to get to unit-wise? Now use unit analysis. Whatever I'm trying to get to goes on top of this ratio. Whatever I'm trying to get rid of goes underneath. In this case, moles of water. Down here, grams of water. And where do I get that relationship? Right here. 1 mole of a compound equals its molecular weight. And I'm about to sneeze. Hold on. Ooh, that was a good one. Excuse me. By the way, I sneezed into my elbow, so you're all safe. 1 mole of a compound equals its molecular weight. For water, is 18.0. Before I pick up my calculator, remember, anything divided by itself equals 1. Grams of water divided by grams of water, 1, cancels out. I'm left with my answer in the right units. Remember, this is 3 significant figures. This is 3 significant figures. This is an exact number, which does not have a row. So my answer should have, for multiplication and division, the same number of significant figures as the number that has the lowest significant figures. And since I don't want to leave you hanging, and if you notice, if you do the math, get this number, rounding it off to 3 significant figures would be 0.486. And that's how you do it. Remember, when you're doing unit analysis, whatever you're trying to get rid of goes underneath this ratio. Whatever you're trying to get to goes on top of the ratio. All right. I haven't hit you up too many times. Thumbs up, people. Can you see chemical equation? Thank you. All right. You should know chemical equation is a statement about a chemical reaction. At the base of the arrow, you have the reactants, which Dr. White, me, will sometimes call starting materials. At the head of the arrow, you should know, are the product or products. Now, in a chemical equation, it should always be balanced. And if you have to balance it, which on test number 2, there's going to be 4 balancing equations, 3 points each, that's 12 points. This is an important skill, so you should know how to do that. Let's see. And there should always be the same number, same type of element on each side of the chemical equation, each side meaning each side of the arrow, reactants and products. You can only change the coefficients in front, but not the actual structure of the molecule, which students try and do. My advice, always leave oxygen and hydrogen last, and remember the even odd trick. We went through this. By the way, I don't have time today, but tomorrow at the beginning of the lecture, and this I will take off the Zoom video. So if you missed it, you can come to my office hour and I'll show it to you. I will go through the answers for the lab on balanced chemical equations, which I've already graded and put Blackboard. Now, once you have a chemical equation, you can use that to find out mass calculations for reactions. And that's how many grams of a starting material do you need to make a certain amount of a product. And you have to do 3 steps. First one will be convert whatever you're given in grams to moles of that, which you've learned how to do. Second step, moles of A, whatever you just converted, convert to moles of B. And how do you do that? Let's do one real quick or show something. You'll have like a conversion. If you want to go from moles of hydrogen to moles of water, how do you do that? The relationship, the coefficients give you molar relationships. 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. And that's where you can get the relationships to use unit analysis to do step number 2. Finally, once you get moles of B, and we just went through something like this, or use 1 mole of a compound equals the molecular weight of the compound that goes from moles of B to mass of B. I did a couple of them. They're in the video. They're also in the practice problems. So don't forget, try those. And as I say here, remember that the coefficients of a balanced chemical equation are molar ratios. Finally, limiting reactants, that's when you react 2 things together and one of them runs out first, just like the pen caps and the pen bodies I've talked about. And how do you do that? Determine the number of moles of product produced for using moles of each reactant. Then if you say you have 2 reactants and you look at the 2 numbers you make, the lower one of those is always the correct answer. And that's everything you wanted to know about test number 2. No, not really. Let's do one more thing. On your screen, you should see now, and I'll ask once again my favorite question. Thumbs up, people. Yep, you see it. All right. You should, before Thursday, go and review this. Why? This is stuff you don't have to memorize. Now, I give you the electron shells and number of shells. I don't tell you, but you should know lowest energy 1, 4 is highest. You always fill 1, then 2, then 3. Same thing with the subshells. You always fill S, then P, then D. By the way, can you keep a secret? We don't have to do any D or F. that won't be, because we only go up to magnesium. Next, I give you these relationships right here. And you should know how to use it and use your good buddy, your good friend, unit analysis. And here for the mass calculations, this I'll give you. I'm not giving you on there, and you should remember that the coefficients give you molar relationships between reactants and products. I don't also talk about how to balance the chemical equation. Don't forget, use hydrogen and oxygen last. Also, don't forget about my even odd trick, which I taught you. And finally, here's limiting reactants, which we just talked about. Now, that's all the material for test number 1. Are there any questions? Now, I'm going to do something totally unusual, because as I look up at the clock, I see we're just about out of time. So instead of trying to do something and go way over or rush it, I'm going to do something totally unusual. I'm going to let you out about 2.5 minutes early. Shh, don't tell the dean. But with that, I'll let you go. Don't forget, tomorrow we'll have our regular Zoom meeting. Same thing Thursday, I mean. And if you have any questions, always feel free to email me. And tomorrow night, I'll have my office hours. And if somebody needs it, I'll stay a little later if you need me. With that, I'm going to sign off early saying goodbye, gang gesund, be healthy, and I'll see you tomorrow morning.